Hey, this is Joe at graybenchelec. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Earthquaker Plumes. All right, so the Earthquaker Plumes. This is Earthquaker's take on the classic Ibanez Tube Screamer design. It has some key differences that we'll look at in a little bit. This pedal was sent to me by a viewer. You know who you are. Thank you very much. We're also be doing a little modification to the clipping diodes inside, hopefully installing sockets so the person who gets the pedal back, they can swap out whatever clipping diodes they want. Going over the pedal here, we have a standard 125B or 1590N1 size enclosure, top-mounted quarter-inch jacks. They are the plastic collar jacks with the metal nut. PCB-mounted DC jack there. 3 controls, level, tone, gain. We have a 3-way mode switch inside, or an on-off-on mode switch. One of the modes is symmetrical clipping. The middle position, I believe, is no clipping at all. No diodes in the feedback loop for the first op amp, and the other setting is asymmetrical clipping. Non-latching foot switch, so most likely relay switching with a microcontroller. 5mm LED here with the chrome bezel. The finish is a sort of semi-gloss army green powder coat, and we have yellow silkscreen graphics with the Plumes logo, Earthquaker devices. On the back is the Earthquaker sticker with the serial number, Hemi, Akron, all the different regulations marked down there. And that is pretty much it for the outside of the pedal. Let's go ahead and crack it open. All right, so here's the PCB for the Earthquaker Plumes. So just for reference, this board is marked revision 2F, so it's 2 franc, and the back door here is dated November 5th of 2019. So coming up on 4 years old now for this specific pedal. I don't believe the Plumes has changed meaningfully since then. I know it's still a pedal in their line, so definitely one of their more popular pedals. So probably pretty similar to what you're looking at to what's currently on the market. So major components, we have the board-mounted jacks here, the quarter-inch jacks. They appear to be the Neutrik style plastic jacks. I don't see a maker mark, but that's what they look like. Board-mounted 9-volt DC jack here as well. Our pots appear to be the Vimex pots. They have that sort of translucent clear substrate. The pot values for level is a linear 100K. For tone is a W20K. W, I believe, is a special taper used by Ibanez for the tone control, and in this case also Earthquaker. I don't know too much about it, but there's probably people out there who could tell you. And the gain control is an audio 1 meg. We also have the on-off-on toggle switch here, and this is a tie-way switch. On the board here, we have the blue 8th watt metal film resistors. 8th watt, as we talked about before for pedals, is generally totally fine in terms of power handling. This typical use is 1/4 watt resistors. They're a little easier to deal with, they're a little bit bigger, but 8th watt is perfectly fine in terms of power handling, and it saves space on the board. The orange component here, this is the relay. This is what does the switching for the input and output of the pedal. And that relay is going to be controlled down here with this IC. The IC is actually, it looks like they sanded down because I can't see any markings on the IC. But it is a, 1, 2, 3, 4, it's a 16-pin surface mount IC, and then the little transistor package here is actually a voltage regulator providing most likely 5 volts for the microcontroller here. And the microcontroller interprets the signal or the connection that's made by the foot switch to send a voltage to the relay here to open or close its switches inside. It's a 2 switches because it's a double pole, double throw relay. The smaller IC here, this is a 7-pin IC, or excuse me, 14-pin IC. That is a TLO74. So that's one of the changes that Earthquaker made to the original Tube Screamer. The original Tube Screamer had BJT transistor input and output buffers. The Earthquaker here switched that out for two of the op amp stages inside the TLO74 are now just used as unity gain buffers in the same way that Tube Screamer used the BJTs. So it's a TLO74, that's a quad op amp, and 2 of those are used for input and output buffers, just like the Tube Screamer. That'll give you better impedance, better input impedance and output impedance compared to BJTs. And it simplifies the design because you can just use one of these quad op amp packages. Over here, tucked in the corner between these electrolytics is the voltage inverter. That's the other major change I would say Earthquaker made to the Tube Screamer, is they use this voltage inverter, which is a 1044 TC1044 voltage inverter, to provide both positive 9 volts, which is the input voltage from your power supply, and negative 9 volts from the voltage inverter to create a bipolar power supply for the op amps. So what you won't find here, like a Tube Screamer, is a voltage divider with resistors to create that half supply voltage, like 4.5 volts or so, in order to bias the op amps so you can swing positive and negative. In this case, Earthquaker uses the positive 9 volt input plus the negative 9 volts to create that positive 9, negative 9, 18 volt total swing around the op amp. So you'll get more headroom out of it. The op amps won't clip as much. The diodes are absolutely going to be doing the clipping, except for that middle mode where the diodes are out. If you're getting clipping in that stage, it's from the op amps, it must be. So yeah, we're expecting for that bipolar supply, the Plumes is going to be louder, it's going to be cleaner, and any clipping you hear is most likely going to be diode clipping. And that does make sense because they've used for diodes here, they do have asymmetrical clipping via the standard like 4148 silicone diodes, but the symmetrical clipping is with 2 red LEDs, which will have a higher threshold voltage, which means you're going to want that extra gain available from the bipolar power supply in order to drive those LEDs into clipping. As far as capacitors, we already looked at, there's a couple electrolytics here. This one is a Illinois capacitor, the smaller black one is a Nichicon, and the smaller gold one should also be a Nichicon. The film caps here, the red film caps, these are Panasonic's, I believe. I don't see a marking, but usually that's the brand for the maroon capacitors. There's a couple ceramics floating in there, and then one of these box capacitors that I cannot see a brand on. The foot switch, it's a single pole, single throw, non-latching foot switch, so just a momentary foot switch, and the brand is SCI. The pots here, you can see, they don't have the typical plastic pot covers. So that's these pieces here. This is the normal way you do this. You just put these covers over the back of the pot, and that protects it from 2 things. It protects the back of the pot from shorting to any solder connections on the board, but they also protect the open slot at the back of the potentiometer from dust getting inside. So Earthquaker recreated one of those effects with this sort of foam, it's like 1/8 inch foam stuff that they cut in little squares and then stick to the back of the pot. It's not protected from dust as well without the cover, but inside of a pedal, how much dust is there really? I think it's a reasonable compromise, and I suppose, assuming that maybe they get these made for them, the little foam pieces are cheaper than the pot covers, which would make sense. For grounding, Earthquaker has one of these little spring tabs, and that should match up to a section of the enclosure here that was protected from the powder coat with a piece of tape. So when the PCB sits inside the enclosure, that spring tab pushes against the bare metal of the enclosure here, grounding the enclosure to the circuit ground, which provides EMI protection. All right, so looking quickly at the schematic for the Plumes, if you've seen a Tube Screamer schematic, it should look very familiar. The exception, of course, is we have now this voltage inverter. This is like I said, a TC1044. It's taking the 9 volt input from your power supply, going through a protection diode here, and then passing that straight through for 9 volt for the positive voltage input on the op amps. But it's also sending it through here, the voltage inverter, which is creating a negative 9 volt supply, and that's going to be connected to the negative voltage input for the op amps, the TLO 74. I wrote 2, that should be 4. So we come in here through a couple resistors here. This sets the input impedance along with the 1K input resistor, 33 nanofarad cap to block any incoming DC voltage on the guitar signal. 10 meg resistor here connecting to the positive input of the first op amp stage. It's not actually an op amp, it's just usually, I mean it is an op amp, but it's used as a unity gain buffer, so there's no voltage gain. Out of that, throw a 1 microfarad cap, another 10K reference resistor here for the first op amp stage, first gain stage, and here's the mode switch. So this is a 3-way switch. On one way you have the symmetric clipping up here, which is the LEDs. The down side here, this is the asymmetric, so 2 diodes one direction, 1 polarity, 1 diode the other. And then there's a middle position that's not shown that's not connecting either set of diodes. And then you have your gain control. There's going to control the resistance in the feedback loop, which is going to affect your voltage gain out of the stage. And then a little filter coming off here with the 100 nanofarad and 47K connecting to ground. We come out of that through similar connections as a Tube Screamer. Then all this is right from the Tube Screamer tone control. The values are a little bit different, but this is what a Tube Screamer tone control looks like. And this 56 picofarad cap is added. That's not in the Tube Screamer. That's just going to handle a little bit of high end. Out of that, through a couple components, level control here, and this comes down here to the last op amp unity gain buffer to the output of the pedal. So those are the big changes that Earthquaker made. They added a bipolar power supply with the 1044. They added diode clipping options, and they switched the input and output buffers to op-amp based buffers rather than BJT buffers. You could also argue that the use of the TLO74 versus the 4558 being a JFET input that the TLO74 is, that's going to give you a little extra something. I don't put much stock in changes to op-amps, but yeah, that's also a change that Earthquaker made. All right, so like I said, we're going to do a little modification to the pedal here. We're going to pull out these two red LEDs, hopefully try not to damage them, but if they have to go, then they have to go. And we're going to put in a couple sockets there instead so that the owner of this pedal can swap in and out whatever clipping diodes they want for that asymmetrical setting going forward. The solder pads for those LEDs is sort of covered up by the tone control here. So I'm going to try and just very gently bend this out a bit so I can get access to that. And hopefully I'll be able to just heat up those solder pads and just pull the LED out. We'll give that a try first. I don't think I can get my nozzle for the desoldering gun in there, so we're going to try just heating up both sides and pulling it out. All right, so there we go. The modification's done. I installed the sockets as you saw. I tried to do the sockets across. That way they're a little more stable because it's a longer socket, but the spacing this way on the board isn't the standard 0.1 inch or 25 or 2.54 millimeter spacing. So that didn't work, so I had to use two shorter sockets this way. I was able to get the original red LED clipping diodes out of the circuit without damage. So those are going to go back to the owner with the pedal. If they ever want to go back to the stock sound, they'll be able to do so with the original clipping diodes, LEDs. As you saw, I installed two germanium clipping diodes here because that's sort of what the original owner wanted. These are Japanese Hitachi. Where's that? I just had it. Yeah, these are Hitachi. That's the logo there. It's Hitachi 1N60 germanium diodes. As you saw, I tested them and they're testing a little high. But that's at 5 milliamps, which is what the DCA 75 and DCA 55 test at. So it's probably more down to like 0.3, 0.4 at a standard like 1 milliamp test. Funny thing about 1N60s, you have to be careful. There's 1N60, which is a germanium diode, and then there's 1N60P, like Paul, which is I think it's a Schottky diode, and they often get mixed up with each other. So make sure, it's very likely that 1n60s, if they're real germanium, they're going to be point contact diodes like these here. There's also very few point contact silicon diodes, and so these are, when you find point contact diodes in general, they're almost definitely germanium. All right, so I think that's it for this pedal. Let's go ahead and wrap it back up. All right, that was the teardown and modification of the Earthquaker Plumes. If you have any questions or recommendations for a pedal you want to see on an upcoming teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing. I am Joe from Graybench Electronics. Thanks for watching.